Okay guys, so in this video we are gonna look at the oxidation of oxalic acid that we did in the previous video, and we are gonna construct an overall balanced equation using the manganate to manganese equation, half equation, and the oxalic acid to carbon dioxide half equation, and are gonna do that using the redox method. We've talked about all this in the previous video, how we got the charges and stuff. Now let's come to the main method of balancing. Okay, manganate ions give rise to manganese ions. Okay, this is all that we know, right? First of all, I need you guys to know the three rules of redox before proceeding. The first rule is that first we balance for the charge. First balance the charge. By the charge, what I mean is first balance the number of electrons. Number of electrons. So how to balance the number of electrons? Well, it's easy. This is a basic rule of redox that the number of electrons which are lost must always equal the number of electrons which are gained. Okay, so this is the first rule of redox, and we are gonna need to balance the number of electrons in both the equations. Basically, we are gonna balance the electrons from the species which is losing them, and we are gonna balance the electrons for the species which has gained them. The second rule is that in order to balance the oxygen atoms, to balance oxygens oxygen atoms, we add water molecules on the other side of the equation. Water on the other side of the equation. On the other side. So basically, I'm gonna talk about this while balancing the equation, but this is the second rule. And the third rule is balance the hydrogen atoms. If we need to balance the hydrogen atoms, add protons to the other side. Protons to the other side. H positive ions basically to the other side of the equation. Other side. Okay, so these are the three basic rules in order to form a complete equation. Now let's start out by looking at the rules. We know that manganate is being converted to manganese, and the charge of +7 in manganese is being reduced to +2. The charges are only reduced when the species gain electrons, and in this case each one manganese atom is being converted into one manganese atom ion. Basically, yeah, one manganese is being converted to one manganese, and each of the manganese atom over here is gaining 5 electrons. Each of the manganese is gaining 5 electrons because the difference in +7 and +2 is 5. So on the reactant side, in order to balance the charge, we add 5 electrons. 5 electrons are being added. So manganate ion gains 5 electrons to form manganese. Okay, and let's write down the second equation as well. H2C2O4 oxalate is being converted into carbon dioxide. In this case, okay, now first we need to balance the carbon atoms, okay, because the carbons are different, and the species that is changing in oxidation number, the number of that species must be same on both the sides. So two, let's place a 2 over here as well, the 2 carbons and 2 carbons. Now each carbon atom over here has a charge of +3, and each carbon atom in carbon dioxide has a charge of +4. Now, from going from +3 to +4, it has to lose one electron. But since there are two carbon atoms, so two electrons are being lost. Each carbon atom loses one electron, and two carbon atoms lose two electrons. Okay, now look at the first point that we wrote over here. Balance the charge, the number of electrons. Now the electrons which are lost from here must equal the electrons that are gained over here. So in order to balance the electrons, multiply this entire equation by 5 and multiply this entire equation by 2. Basically what I've done is I've multiplied the number of electrons over here in this equation by this entire equation, the 2 over here, and I've multiplied the number of electrons in the first equation by the entire second equation, 5. So this basically gives, this makes this equation 10 electrons plus 2 manganate, forming 2 manganese, and over here it forms 5H2C2O4, forming 10 carbon dioxide and 10 electrons. Okay, so the number of electrons lost and gained are balanced. Now the next step is, okay, now we need to join these equations. Now to join these equations, right, copy this equation beneath the first, beneath this equation. So copy the manganese equation, 10 electrons plus 2 manganate forms 2 manganese, Mn2 plus. Now let's combine both the equations. Whenever we are combining the two equations, the species on both the sides of the equation gets cancelled out. Okay. So basically, oh, where did it go? Oh yeah. So basically, this 10 electrons and the 10 electrons get cancelled out, and then the equation that we form is 5H2C2O4 plus 2 manganate forms of 10 CO2 and 2 manganese. Okay, so the first step is cleared. Now let's come to the second step. The second rule states that to balance the oxygens, we add water molecules. Now let's count the oxygen on this side. There are 20 oxygen atoms, and the oxygens on this side, 5 fours are 20 and 28. There are 28 oxygen atoms. So 8 oxygen atoms are greater over here. So we need to add 8 water molecules on this side to balance the extra 8 oxygen atoms on the other side, because the rule is to balance the oxygen atoms, we add water molecules. So 8 water molecules that balances the extra oxygen atoms, and then the last step is balancing the hydrogen atoms. We add the H positive ions on the other side. Now let's count the H hydrogen atoms. There are 5 twos are 10 hydrogen atoms on this side, and there are 8 twos are 16 hydrogen atoms on this side. So 6 hydrogen atoms are greater on this side. So in order to balance it, we add 6 H positive on this side of the equation, and this is our overall redox equation prepared of the above reaction. So oxalic acid is being converted to is being oxidized by manganate ions. Oxalic acid is being oxidized by manganate ions. So oxalic acid gets converted to carbon dioxide, and this is basically oxidation. Whereas the oxidizing agent itself, the manganate, gets reduced to manganese 2 plus, which is reduction. Okay guys, Now let me tell you one thing, one very important thing, that this equation is very important with respect to the past papers, and it has been asked several times to balance this equation. So you guys should know how to balance it. You guys must know the important steps if you need to balance an unknown equation. So these are the steps, these are the simple steps that you need to follow. And the number of electrons, please be careful of the number of electrons. Okay, so this is a very important equation. Keep it in mind. And that's it with balancing redox equation with respect to the carboxylic acid chapter. Okay guys, so in the next video we are going to talk about acyl chlorides. Finally we are done with benzene and carboxylic acids, and in the next chapter we are going to start out with acyl chlorides.